This conference will now be recorded.
All right, so those are the different shells: Z, C, K, and born. Right, so you can have different shells. All right, and by default for Red Hat is the Bash shell, and that's when we start talking about Bash scripting. So let's go here, Bash scripting, and you can download this book for free. Like you just type in Bash scripting PDF, and I'm sure there's a PDF that comes up. This is very old. This has been around forever. Um, but yeah, you can see here beginning, right, Bash scripting. You can just download a PDF of a book. There's plenty of books out there that are free. They may be a little old, but you can see here they automatically start you out with the born shell, the C shell, the corn shell, and there's the T shell, right? And they just talk about the shells and what POX is and so forth. Um, I mean, yeah, I mean this from 2009, Evelyn. I put it in there, but it's an old book. That's why I say you'll probably find something newer. Or I send this to D and D can post it. It might be practical. I don't know. It might be practical. Maybe, maybe not. Um, it's just Bash, right? Do you all know who the founder of the Bash shell is? I've spoken on him before. Look him up. His name is Brian Fox. There's Brian Fox right here. Born in 1959. Let's see. He is the original author of the GNU Bash shell, which he announced as a beta in June of 1989. Linux was not didn't come out officially until 91. He continued as a primary maintainer of the Bash shell at least until 1993. Right. So that's a little bit about Brian Fox and the Bash shell. Right. But like I say, this book is an old book, but it's still. I mean, it should still work to cover the basics, right? Just the basics. All right. So let's get back to the class. Is this similar to PowerShell? Mm, I don't want to say it's similar to PowerShell. I'm gonna say you can do similar things in PowerShell that you can do in Bash, but it'll be totally different once you write the scripting link, once you write the script up, if that makes sense. Like in PowerShell, if I want to read a directory, there's uh certain commands that I have to put into that shell script in order to do that. Same way with Linux. I couldn't take a PowerShell script and then put it onto a Linux box unless I have PowerShell on that box. And we found that out uh, when we talked to what his name just escaped me just now. Who did we just have on D? What was his name? Oh, what is his name? Oh God, I
You
have to
mean
go to
Scott? Scott
yeah, Scott.
Hanel,
Yeah, Councilman.
Hanselman. Okay.
Yeah. Where's your sidekick at? Yep. Scott is the one that was saying that PowerShell could be installed on Linux, right? So if you wrote a PowerShell script on a Windows box, not necessarily for a Windows box, right? Maybe just listing a directory, but not opening up system the C drive because you probably wouldn't have a C drive unless it's mounted onto the actual system, if that makes sense. All right, so when a shell is used interactively, it displays a string when it is waiting for a command. So when we was looking over here, right, we're waiting for a command. You're telling me like, hey, that flashing light. Oh, you want me to? I'm waiting for something. What do you want me to do? I'm waiting for you to tell me what to do, right? Remember, you are controlling what this operating system is going to do. You're giving it instructions, right? So let's go back over here. I should close this one because I'm gonna keep going to that tab. All right, so now it says you're waiting for a command from the user. This is called the shell prompt. When a regular user starts a shell, the default prompt ends with a $sign, right? And if it's a root user and want you to clarify, want you to look here how they have it spelled out for you, just a regular user with the $sign. The key is the $sign if we're in the bash shell. And then root if is the £sign if the user has root permissions. Now root permissions is just like having an admin permissions on a Windows box. You have the power like He-Man. I have the power. That's what this is, right? So it says using bash to execute commands can be powerful. The bash shell provides a scripting language, and we saw who created that. And the shell has additional capabilities that simplify or make operations possible. So what happens in a bash shell, and you're going to learn this throughout this course, is if I want to create, and this is the hard way, the easy way will probably be you should be using Ansible. But you can use a bash shell to create 15 users with unique IDs, with home directories, and uh, uh, a and a different shell that they log into it. So let me show you what I'm talking about here. We can use this little scenario to give us what we want. Let's see if it'll let me do root. I'm gonna sudo su dash. Yeah, it's not letting me do that. Let me see. Oh yeah, hold on. Let me do this. Let me exit out of this because I am that user. Okay, I'm already root here. That's clear. That's cool. So let's go and look at let's cat /etc password. And I'm gonna pipe this over to less. And I'm gonna explain this command real quick. So what a cat is a way to read a file. So if I want to read something, if I'm in Windows, I just double click on it, right? If I'm in Linux and I'm on the GUI, I can just double click on it. But what happens when I'm not in the GUI and I don't have a GUI, GUI, graphical user interface? If I don't have that, how do I then see what's in that file, right? So we have a word called, or command, I should say, called cat. C-A-T. I'm going to control C. So you can do a man on C-A-T, and it's going to tell you concatenation files and print out standard output. All right. I'm just going to cat a file. That's all I'm doing. Just standard output. So I'm going to cat in this password file, which is where all my users are contained. And this is the path in which this is the path in which password WD is in. It's in the /etc folder. And I'm going to break down these folder structures as well too, right? And then we're going to cat, and I'm going to use the pipe command because I don't want it to scroll off the screen. Let me show you what happens first. Scrolling off the screen. I don't know what's going on. I can't see nothing. So now if I do my up arrow, which you can do the up arrow on all your Linux systems, and pipe that over to less and then hit enter, now I don't get the scroll off my screen, right? So now I see, now if I wanted to create all these users, I would need a bash script in order to do this, unless I want to sit here and do this 15 times. The goal of you as the admin or as the DevOps engineer or what have you is to automate yourself out of the situation, right? You always wanted to continue to automate yourself out of the situation. So you can write a bash script for this. You can use a PowerShell script. You can use Puppet. You can use Ansible. There are multiple ways to do this. Right now, we're just sticking to bash. So here we can see there's a user called root, And the reason why I know there's a user call root, because there's a dead giveaway on this line here that tells me that this is a user and that user can log in. Can anybody tell me what's unique about this line versus the second line? What's the difference that you see other than the usernames?
Oh, I was gonna say that admin versus regular user, but that may not be the answer.
But no, what do you see on the line though?
Uh,
I
I
give
see
you a hint.
root on the first one.
I give you a hint. It's at the end of the line.
Oh, okay. Like so, Ben Bash,
Yep,
and
yep,
then the no login on the other one.
yep. So what's unique is, and how you can tell really, really quickly whether a user can log in, right?
Uh,
So Ben Bash is that shell that we were talking about, right? So that Ben Bash says, hey, you're a root user, you're gonna get a shell. Your default shell, it's gonna be Ben Bash. But this Ben user is probably more than likely some type of service, and they're gonna get an SBIN no login, meaning I can't log in from the command line prompt as Ben. Same way what you see as the daemon here, I can't log in, right? And so you're gonna find this out a little later, but there's another uniqueness about these as well too, right? And the uniqueness is every service that you have on your Linux box actually has, if it needs a not a home directory, but a place to store its log files, or of want to keep its own log files or something like that, has to have some type of service user. And there are special numbers that we have to use, like anything below 1095, if I'm not mistaken, is saved for the operating system, kind of like reserve words if you're into programming. And then usually we make anything above that. Usually we start at, like, most people are started like 6,000 or something like that for a service. That's why you often see when somebody installs something with Java or something like that, there'll be like port 8080 or port 8000 or port 8081 or something like that, or port 5000. It's because we have a set of reserved services for we have a set of numbers that are reserved for our services. So that's why you see that. Any questions so far? No? Okay. All right. So now when we get into here, they show right here, they say bash is similar concept to the command line interpreter, CMD for and this is on Windows, so cmd.exe. So when you go into your search bar, you type in CMD and you get a prompt that pops up. That's really cool. So now I can enter some commands in order to do something. This will be the same thing, right? And the same way I showed you my shell inside of my Unix box or my Mac box, right? So it says commands entered at the shell prompt have three basic parts, which we've been going over: the command, the options, and the arguments. Well, let's go to our class and let's open up a shell. Let's open up Server A, and they give you the actual let me see, let me click out of here. They give you the actual oh yeah, it's not letting me make it bigger. Let me go here. They give you the actual zoom in is command equal now. Okay. And don't like me. Let me just stick to this one. They give you the, okay, is that a little better? No? That's why I was using this one over here. But we'll stick with this one because I think you can see this better. I'm gonna go LS. All right, so when they talking about you have oops, let me go back. Chapter 2. Accessing the command line. Come on. You can do it. Oh, here we go. All right, when they're talking about the command, the options, and the arguments, they're actually what they're talking about is when I did a man on, say, LS, right? They're saying that you have the command and then you have what we call right down here, these are options that I have that I can use with it. And then they talk about the arguments. So I can adjust the behavior of the command. So let me show you what they're talking about. So I'm going to CD over to etc. Now I can just do ls, right? And it's just going to give me a listing of what's in there, right? And then if I go back, and let me make this wider. If I go back and now I'm going to change the way the command actually functions, or using an option, when I do a ls minus l, I now get a long listing with additional information from using an ls minus l. And so that's what they're saying here. Like, you have to understand how a command works, right? So you have options and then you have arguments. So now the argument part is this. Let me clear here. Let me go over here to my home directory. All right, so now when I do a ls and then I do a minus l, that's my option. And then when I do etc, that's my argument. So what I'm telling is, hey, give me a long listing with additional information. You can look up what the minus L gives you in of the directory of etc. Now, before we do that, let's get the proper terms of what the minus L gives you. It may just say long list. Let's double verify that. So we're going to go down here. We're going to look for the minus L and it's lowercase that we want. Yeah, just it's right here. Use long listing format. Okay. All right. So what I'm telling it is do a ls, give me the long listing of /etc. I can clear my screen with the word clear, and I can do my up arrow twice, and I can say, give me the long listing of var log messages, right? I mean, I should say var log, not var log messages, but var log. Remember, it's of the directory. And if I want to read a file, then I have to use the cat command in order to do that. But they're just showing you how an actual command is laid out, right? So let's go over this. ls minus l slash pwd. What explain to me each piece. What is the ls part? Nobody?
List.
But it's a command, right?
Oh, I'm sorry. Yes.
It's the command. And then the minus L is the what?
The option.
And then the slash PWD is the
Argument.
argument, right? So here is my command with an option on this with for now would just say on slash PWD or the argument. So I can do a long listing, but I want to get fancy with it. I want to do more with my ls command. So I'm going to go back and do a man on ls, and then I'm going to say what else can I do here? Let's see. Let's see. Give me a list of directories. Um and not their contents. You notice that. Just give me a list of directories and not their contents, right? So now let's do a ls. Let's just do a capital use a up arrow. And let's go back and do this on slash on etc. Let me see if it's gonna. Okay, yeah. I think this is the trick you have to do. You have to use. I don't think you can just do it on here. Let me look. Can I do it on star? Would it give me directories under that? Yeah. But it's giving me everything under etc. And I just want directories. So let's go back. I think there's something else I have to use with the directories. And I forget. Let's find out.
You mean directories under directories?
Mm-hmm.
Isn't it capital R for
Let's
recursive?
find out. Oh well, I should have been able to use the D, but I think you got to use D with something else. Let's double check. Because what you're doing is recursive. And
Yeah.
I don't want to do recursive. So I should be able to do a listing of directories under that. But let's try it. I think it's going to give me everything else. Is it LD? That's what I thought.
Oh, just the okay.
Yeah,
LD.
just the
Yeah.
just the directories. I don't like it either. Let's try it with the star. Yeah, see, it's still doing it with that. Let's try it with the capital R. Yeah, see, it's giving me everything under it. I just want to get a listing of directories under etc. So let me see something here. Let's clear. And then let's go over to etc. And let's do it ls minus d. See, it doesn't like that. See, what about L? Yep, not like that either. How about star? Nope, it's still giving me the same thing. It's giving me files. I forgot there's a trick that you got to use in order to get just the directories themselves. But nevertheless, I think you kind of get the point when you're looking at this. Now, um, another thing that you may have noticed is the colors. Um, in the Bash terminal, over the years, it didn't used to be this way. I can tell you what doesn't give you colors. I think you have to set it up in the terminal. It's PuTTY. When you use PuTTY to SSH to a box, I don't think PuTTY gives you the colors. But the colors are helpful because they're really dead giveaways. All right. All right. So when I do a ls minus L here, uh, the ones in blue uh automatically by my eyesight, and we will double verify this. The ones in the stuff that's in blue are directories. The things that are in green or like I don't know, a blue green if you want to call it, those are links, and things that are not that don't have any color to them are actual files. But we can double verify those things. And we can double verify those things by looking right here at the very when we do a long listing. We can double verify whether something is a directory, a file, or a link. The D out in front stands for directory. Nothing in front makes it a actual file, and then the L in front makes it a link, not a list, but a link. So the D right here in front of these permissions tells me that this is a directory. Nothing in front of these permissions, the very first in that very first column, this right here, tells me that that's a file. And then with the L in front, that tells me that's a link. And not only is it a link, it's a soft link. And we'll get more into that later. But I want to give you the visual to know that there are directories, files, and links. In order to read a file, you need to use the cat command, or you can use vim or pico or nano, but cat for now works. If I want to know if something is a file, another way, So I'm gonna do a ls minus l here. Let's look at tcsd.conf. So I'm gonna clear my screen. If I want to know if something is a file, I type file tscd.conf, and it's gonna tell me, is that not it? Let's grep ts. Okay, tsc. What was it? tcsd. Cool. All right, file tcsd.conf. Right. So that tells me it's an ASCII text, right? I can also do file. I can also use the file command on directories. So let me do it ls. So let's do it on httpd. So let's clear and do file on httpd, and it tells me it's a directory. So I gave you 3 different ways to tell me whether something is a file or directory or link. So let's clear and let's do it ls minus l, and let's look at the link system released. So let's go clear and let's do file on system release. It's a symbolic link, and they tell you what it links to. So you have multiple ways to tell where something is a file, a directory, or a link. So let's test this out. Let's see how quick you are. Let's see if you recognize this real quickly. All right. Joan, term info. Is that a file, directory, or a link?
Directory because it's blue and it has a D in front of it.
There you go. Boom. Evelyn, vimrc, file, directory, or link. And I have it highlighted. Oh, did you type it? Let me see. All right, cool. All right, next person up. Kiara, what's going on with you? Let's see where you at. Yum.com, file, directory, or link.
That is definitely a link because it has the L in front.
You got the L in front. What's another way that I can find out if if it is actually a link? Suppose I don't have the colors in front. I got the L, but what I want to double verify what you're actually saying. What can I use? What command can I use?
You definitely just said that. I know it's something that we can put in at the bottom to figure out if it's a link. Can
The
you refresh
file command. The file
the,
command.
okay.
So if I type file on yum.conf, it tells me that it's a symbolic link. So
Got it.
the file command is your friend. The file command helps you when you are in a bash script and you're writing a bash script and you want to know if the output of what you're doing actually returned a file or it returned a directory. So when you start writing a bash script, you can check to say, hey, is this a file or is this a directory or is this a link? And if it's a link, go do this thing. If it's a file, go do this thing, right? So you're going to start learning about conditionals.
Okay.
Right? So that's good. You're paying attention. That's awesome. All right. All right, so let's go back to the class. All right, so and so I think you got an idea of what the breakdown is of a command, the options, and the argument, right? Here they're showing right here options start normally with 1 or 2 dashes, and let's go back to that where they're talking about the dash A and the dash A and dash all. So let's clear. I usually take the shortcut, but let's do a man on ls. And so here they're saying, hey, I can use the dash A or I can use the dash all. Let's try the dash all. Let me quit here. And then let's do a ls dash all. So you can see the dash all. It's gonna print everything out for me, and I can do the dash A, gets me the same thing because they're the same command, right? And that's what they're showing you there. All right. So now let's go back. Here they're just breaking down. You have a command with options and an argument, right? So here the command, the option, and the argument. Now they're talking about logging into a computer to run the shell. You need to log into a computer. You're going to open up a terminal, which is text based. And then I won't read all these things, but they'll show you, like, if you are on a desktop, you can use Control Alt and use the function key, and it'll give you different TTYs. And those TTYs are different terminals. TTY is what I said, right? Uh, TTY. So you'll have 6 different terminals. So let me clear. And if I went to /dev, and then I'm just grep for TTY. Awesome. Should grep. So you see here, you got different terminals here that pop up. So you got multiple terminals in here that'll pop up. But you'll have basically on your Linux box TT0, TT1, TT3, TT4, TT5, all the different terminals that you can use if you are on a physical box and say that the GUI didn't render. You can hop over to TT0, TT1, TT2, TT3 to type in some commands, to log in, type in some commands to get the box back up, right? So that's just another option there. Oh, is it a slash? Let's see. ls minus l d oops d slash etc // yeah, that works. So it gives me all the directories under that. What if I do it without the slash? Did I try that and it just gave me everything? Yeah, it did. So you gotta categorize it, which is funny, but nevertheless that worked. It gave me all the directories under /etc that are directories. Now if I want to, again, if we wanted to do well, I was using grep because I like to search for stuff when we're using grep. So it's another a way to filter. So let's clear. So if I do ls minus l, and I want to, and you're going to go over this in the class more, so I'm kind of skipping around in here, but you'll see it. I want to grep for everything that starts with mu, and the caret at the front is going to give me starts with. And so there's probably no mu. Let's do et maybe. I don't know. Let me see. Okay, let's do fi. Everything that starts with fi. Oh, it don't like me? You should work. Starts with. Okay, how about starts with an F? That should work. Huh.
Yeah, use the
Yeah.
asterisk.
Mm-mm. Because it should grab everything. Well, let's try. Yeah, see, it should grab everything that starts with an F, not has an F in it. And that's the thing. But it should have grabbed everything that starts with an F right there.
But I'm saying, do you take the caret out and just do a F asterisk after that? You know.
Well, the F asterisk will give me everything that starts with an F and anything afterwards.
Oh, okay,
All right.
gotcha.
Well, yeah, so see, it grabbed me firewall D and fonts, and they telling me it's a directory, and so it can't do anything with that. So I guess there's no files there. Let me see. Do I need the $sign at the end? Let's find out. Nah, I should have grabbed me everything with that starts with an F. Do I need the $sign? Let's find out. Yeah, that didn't work. Let's see, starts with. grep starts with right here. Should be the. I may have to pass some other options. Let's go and look at the grep-e. Let's go back over here. Let's do a man. Oh, don't ask again. Man on grep. My -e extended regex. And no, and the lower case e is. All right, let's see something here. And I did this last year. Oh, let me get rid of that. Don't like that. Let's do a capital. Yeah, like none of my stuff. I'm gonna have to go to the chapter now. Hold on. Let's get through this one real quick. I'm gonna come back to it. Okay. So then here they talk about TTY1, and here they start talking about the graphical login screen runs on the virtual TTY1. So in other words, it runs on your first terminal. I'm gonna come back to the greps. All right. So here it says in Red Hat 67, the graphical login screen runs on the first virtual console, but when you log in, your initial graphical environment replaces the login screen on the first virtual terminal instead. In RHEL 5, you don't worry about that because you're not in RHEL 5, you're in RHEL 8 now. All right, so then there's like a headless server does not have a keyboard and display permanently connected to it. A data center may be filled with, yep. So if we're in the data center, we may be filled with using a KVM in order to get to the machines, or we may not have any type of KVM set up. We may have to use, if you're on a HP side, you may have what we call an ILO. Let me show you that. ILO HP image. So let's go to images here. So in HP, this is what it would look like, right? This is old, but it get you to what I want to get to. Let me go back because that's in my way here. Show you what it looks like on the back end. Power, no. Maybe this one then. This will work for right now. All right, so the ILO for the HP devices. The ILO for the HP devices, what you have is you'll have a web browser that controls the entire infrastructure. And when I say the entire infrastructure, just like this rack in the back, there'll be a install with these ILOs, and you'll hook them up to like a KVM, and we'll have one place where we can go to manage all these systems, right? And Dell has the same thing too. And when I log in, I can get to see everything about those systems. So I got one console to rule them all, and go from there. So that's what they were saying when they're talking about headless over here. You may have something like a ILO or something like that, and you may not. And so if you don't have anything like that, you have to have some type of way to get to that machine. So on our laptops, we have a wireless connection to get to our machines, or you can have a physical hardwire connection where you're running an Ethernet port directly from your router to your actual machine in order to get, faster bandwidth and so forth, right? And so that's the other way, because once we plug that in, we should be able to get an IP address. You need an IP address associated to your machine so you can get out. So here they're showing you like, okay, well, I need to SSH to that machine. What they don't show you is that machine needs to be on a network. It needs to have a user that you can use. It needs to have an account that is accessible by you that you can use, an IP address and firewall. But they kind of skipped over that, and that's okay because you're going to learn about that later on, and you may already know it. So in our Linux worlds, we use SSH. right? So here they're using SSH as a regular user here because we see the $, and remote user at um remote host, meaning that user has to exist on that box that you're going to. If that user doesn't exist on that box, it's not going to let you in, right? And then because we don't have our keys and stuff set up, we have to log in with a username and password, and then that'll let you into the actual box itself, right? So here they say SSH, and they talk about eavesdropping and hijacking. There is also man in the middle attacks. When we're talking about SSH, man in the middle. Sorry. Right here when we're talking about with SSH, man in the middle attacks, which often happens all the time. So when we are, oh, do I need a single quote? When we are in our when we're in our machines, and our machines are made public, and it's wide open to the public, imagine how many attacks you get on that machine. You get sometimes you get a denial of service attack, or you're just getting constantly they're just hitting your machine to take it down or to try to compromise it, right? You'll get dictionary attacks where people use common dictionary words to try to log in. So what most people do is turn off, not necessarily turn off SSH. They'll take SSH and put it on another port. They'll take SSH and only allow a certain range of users to log in, and only a certain range of users from a selected network or IP address. You see that commonly on your AWS machines. If you make it public, you can go in and lock it down and say no one can get in unless you come off this private network. And if you don't have those credentials, then you don't get in. So that's how they do that, right? So let's go back to the class. All right, so here they're showing, okay, well, if and this is really comes down to your PIM keys, right? Your private keys. Right here, they're showing, hey, I'm this regular user. I'm using SSH, and I'm gonna pass again. I have a command that has some options, and I'm gonna give it an argument. That's how you should be reading that. I have a command called SSH. I'm using the -I option, and I'm going to give it an argument. And I don't know what the argument is. So my best thing I better do is I better go look up and see what my options are. So I should go man SSH, right? And it tells you right here the -I, lowercase I, is an identity file, right? And so we can come down here even further and look at the -I, and it gives you a little bit more context on what -I is. And then you can always do the search when type in /-I, but here it tells you selects a file from which a private key for public authentication is read, right? So that's what that command is doing. This is a private key that you're going to use to log into as the remote user at this remote host. It says for this to work, the private key must be readable. So what they're saying is there's a certain set of permissions that we must have on this key. Now, by default, you don't want it wide open to the world, because if it's wide open to the world, someone can manipulate the key, someone can rewrite the key, and so forth. So they want you to kind of scale that back, and they want you to scale that back using a 600, right? Chmod 600. So now we should start probably kind of like mentioning some permissions here, right? And I'll show you that. All right, so for this to work, they said it must be readable by the user that owns it. And this is so important. When we were doing the ls-l, you saw a whole list of things that permissions that came down. You saw the D in front, but then you saw a set of permissions that were after that. And this is what that chmod command does. The chmod command gives you the ability to set some permissions on a file. So in our case, and for this particular private key, it needs to have a set of permissions set for me, the owner, the big Tammy D, right? All right, so Chmod 600 MyLab PIM, meaning the user has read and see 600 is 4 and 2, so read and write, and no execute. And then the zeros are like the user and the group get nothing, nada, zilch. You can't do nothing with that. I'm not giving you that kind of access, right? And it said, could be used to ensure this, and how to set file permissions discussed in more detail later in this chapter, right? So now they're showing here, first time when you log into a new machine, you may have this PIM key. Now, earlier when we were doing this, you saw we did an SSH and we had a username and a password. Well, guess what? If I have a password and I'm sending that over the internet, it could be easily spoofed or someone can grab it or what have you, and you don't want that. So you want to have some type of PIM key or some type of other way to log in order to get access to this machine. And so here you're doing SSH when you log in, and this is very important right here. This little line right here, actually all of this, right? It says, are you sure you want to connect? Yes. So what happens is when you connect to a Linux server, it does a couple of things. um, it checks to see first off if the PIM is set up and is this private key and does this private key and this public key match, right? Is this the private key to that public key? If not, you can't get in. Another way, if you're using a username and password, is we have what we call Pam modules, right? PAM /D. So let's go over here to this directory. Oh, it timed out on me. That's awesome. Let's see if we can get it started up again. You gotta wait a minute or two, but that's okay because we got this environment over here, but I don't want to use it because you can't really see it. But anyway, we have what we call Pam modules. So Pam modules, Red Hat. And this is advanced, and I know it, but I want you to know it so you can talk about it when you are in your interviews. All right, so PAM modules. Pluggable authentication modules are a common framework for authentication and security. Both Red Hat, single sign-on, Kerbals, and smart cards depend on PAM. So what you're using in AWS, inside of all, even inside of this environment, is a set of PAM modules that are configured in a way to allow you to get in. All right. Programs that grant access to the system use the authentication to verify each other's identity. Historically, each PAM program had its own way of authenticating users. In Red Hat Linux, many programs are configured to use centralized authentication mechanism called PAM modules, right? And so the PAM modules have a common authentication theme. And let me back that down a little bit. PAM provides the flexibility and control over authentication for both the system administration and the developers. And PAM provides a single, fully documented library which allows developers to write programs without having to create their own authentication schemes. And so they walk you through PAM modules and PAM files and so forth. So PAM is found in our etcpam.d directory. So what's significant about the etc directory is where it holds all our configuration files. And they're going to probably get more into this inside of the chapters, but I want you to know the the etc directory is your friend. If you ever want to configure something or know what something needs to get configured at, etc is your friend. Like ET phone home, just etc. Just put a C on ET. That's your friend. All right. So Pam, Aware Programmer, is responsible for defining its service and installing its own Pam configuration modules. For example, login, right? Login defines its service name as login and installs the etc pam.d login. That's an actual file, and we're gonna get a chance to look at it. I'm not gonna go in depth in Pam modules, but I want you to understand what is actually going on, what happens when you log in. There's a set of rules that say that you, the user, has this username, and you're authorized to log in, and this is your password. Remember that file we looked at earlier, the etc password, pass WD? Well, that file contains your set of users that are able to log into your system and have a set of permissions in which they play in, right? And so your PAM modules help you with that. And also when you create your user, you also give your user certain permissions, right? As when we're using sudo or being able to run certain commands or run its root. All right. So they talk about the PAM module interface, authentication, account, password, and session. Authentication authenticates module interface that authenticates use. For example, it requests and verifies the validity of the password, right? The account says it verifies that access is allowed. For example, it checks if the user account has expired. So you may be a user and your account might have got created like 90 days ago, but you only had 89 days 80 days to use the account or what have you. So you may have expired from that perspective, right? Your password could have expired as well too, right? So the password module is used to configure used for changing the user password, and the session module configures and manages the user sessions. In other words, the modules with this interface can perform additional tasks that are needed to allow access, like mounting the user's home directory or the mailbox, right? So the PAM module is the one that's doing the work behind the scenes. You're just SSHing to a box, and then once you get to that box, depending on how the PAM modules, because you can configure them different ways, depending on how they're configured, they're letting you come in and do your thing on that system based upon X, Y, and Z. Now, your system could not be linked up directly to, say, your PAM modules. You could be connected via Open LDAP, and LDAP is found in your Windows systems. So those of you that go to work or log in over VPN, 9 times out of 10, you're probably using like some type of single sign-on and LDAP as well too. And that's going to give you another set of permissions. So again, LDAP works in Windows and it works in Linux. You can have a Linux box that gets its authentication from a Windows server, and passes it back down in order to do X, Y, and Z things. You could have what we call kerbals set up, where kerbals can just live on the Linux side. It can also live on the Windows side, but it's still all wrapped around a set of permissions and services that allow you to do a certain thing, right? So any questions? Did that make sense to everyone? Yep. Nope. Could be. Okay. All right. So now they're saying here that each time you connect to a uh, you connect to a remote host with SSH, the remote host sends an SSH key to authenticate. Now this goes back to what I was saying before. Your PAM modules could be set up to take keys, right? Or you can use SSH keys. Remember, you control and you configure how you want things to work. You're in control of that, right? And it's also set up for encrypted communication. The SSH command compares that against a list of saved hosts to make sure that it has not changed. Now, here's something else that happens when you SSH. It actually throws your host that you're coming from into what we call a known host file. And so when it comes back up, it doesn't say, hey, you want me to add this to known host file. It's already there. And so when it sees you coming, when it sees you SSHing again, it don't ask you that question again. Now, well, there's some things that could happen where an IP address and a host name are associated with each other, but maybe the machine changed the IP address, but the name was the same. It'll say, hey, there's some type of conflict here, and I don't know what you want me to do, so you need to fix that. And so you have to go through and fix that, right? So this goes into if the host key has changed, this might indicate that someone is trying to pretend to be the host to hijack the connection, which is known as the man in the middle attack. In SSH, host keys protect against the man in the middle attacks. These host keys are unique for each server, right? And they need to be changed periodically and whenever a compromise is suspected. So we saw this a lot. I think I want to say the not the log4j, but oh god, what was that? What was that? Oh God, it happened about 2 years ago. It just escaped my mind right now. It'll come back to me. What was it called? Was it it? No, one the Heartbleed. Oh, no one Heartbleed. It was another one that came out where people had to go in and change their SSH keys because of a known vulnerability. Let's see, known vulnerability, SSH keys. CVE. Let me see, I forget what the name of it was. It was a big thing. Let's see. Is this one it? It don't give me the name of it. But you can read it here. The list of known SSH keys used by this plugin is gathered from various sources. SSH keys, vulnerability on Debian derivatives. An attacker could use this situation to compromise or eavesdrop on the SSH communication, but it don't give me what the name of that is. Because it was a big known one and people were running around like, change all the SSH keys now. I forget the name of it. All right. And it talks about you would get this warning if your local machine does not have a host key saved from the remote host. If you enter yes, the host key that the remote host sent will be saved, accepted and saved for future login. So if that changes, it's going to give you an error. And then they tell you to log out. You can type exit or you can hit Control D and you can log out of the actual machine. So let's go back over to here. So they're saying if I hit exit right here, you see I'm out of the environment right there, right? So I would have to start that up again. All right. So now let's go back over here and let's go back up to our table of contents. All right. So we went through, I won't go through the quiz. Let's go through accessing the command desktop. So here, if you're wondering what the desktop looks like, here is the known desktop environment. Right now, it's just a blank canvas, right? It used to didn't be that way. It used to would log in and do your thing and you can just point and click. But now when it comes up, you have to hit activity in order to do that. The desktop environment you're in is known. There are different desktops for Linux, right? So if you go in and type Linux desktops examples, it's going to come back with a slew, right? So you can see here we have KDE, Mate, Unity, XFCE. Just, I mean, there's a whole list of them. Let's go here. This is from 2020, right? By default, GNOME is the desktop of choice for Red Hat. So, but you can see you got GNOME, you got KDE, Cinnamon, Mate, Fluxbox, JWM, Rocks, Equinox, just plain old TTY, just plain old log me into the terminal, and let's keep it going. When I say the plain old TTY, here's the TTY right here. All right. I don't see i3 on here, but I believe you. All right. And then TMW, OpenBox, Fluxbox, Window Maker, so forth, right? So different IDEs. You will have to install these IDEs if you want to have access to them and so forth, right? All right. So here it says the first time you log in as a new user, an initial setup program runs. Now you could turn that off too, but they probably just have it set up to run. Once this is complete, the GNOME help application says get started with GNOME, and you can actually turn that off as well too, so you don't have to worry with like, oh, take me on the world tour. Like when Mac gets upgraded, like, hey, do you want to go on the tour? What you can do? And you're like, no, but you really should go on the tour because you don't really know what you don't know, but you'll figure it out later. That kind of thing. The screen includes the video and the documentation to help orient users to GNOME 3 environment. You can quickly get started here. So here they break down each one of these uh, locations down here under the bottom. I won't go through those in detail, but here they like the one is the top bar. 2 is when you click on activities, it's going to show up this side, and then you have to pick what you want. Here's the terminal that's located here. Here is the web browser here. The default web browser is Firefox. So that gets opened up here. They also show you the system menu in number 3. So if you go up here, here's the system menu right here. Number 4 is the dash. This is configurable list of icons basically for your favorite applications. So 4 is a list of applications, so you can change these out if you need to, kind of like what you do on your docking station in Linux and what you do inside of Windows as well too. 5 is a Windows overview, and 6 is a workspace selector. So 5 is an overview. That's what we saw here. 6 is the space collector. So I probably need to come back down some. So yes, they don't come on screen right here. So but it's over here in the corner. And then 7 is the message tray. So 7 right here was the date, and you more than likely can manipulate this to show what you wanted to show, right? And so that's what they're showing here, right? And they break this message tray and they break it down, right, a little bit more. You got keyboard shortcuts they talk about. In Red Hat's virtual training, the self-paced course training environment used the super key. Using the super key can be a little tricky. You probably cannot use the keyboard super key because it's not often passed to the virtual machine in a classroom environment. And this is a note to how to use some of the tricks in the classroom environment. All right, on the keyboard, treat super as a modifier and the key blah blah blah. So to enter super M on the keyboard, click super and then M if you just want to press super or release. I'm not sure what they're referring to as super on here, but I bet you they're probably referring to here. Do I have yes, hit super and then M. Okay. I guess I don't know. Super capital M. Maybe do I need to be capitalized? Let's see. Turn the cap on. And then let's hit super. And then M. Yeah, nothing happened there. What was supposed to happen? On the screen, keyboard modifier. So to press super plus M on the keyboard, super, then click M. If you want to press and release the keyboard, kick it twice, just hold it down. You can, on the key marker, hit like super on the screen keyboard, hit Shift, Control, Alt, and caps, and then escape, and the menus are like normal keys. Okay, now they're talking about different workspaces. Is there any questions too, by the way, while I'm going? Because we're going to start up a terminal and go from there. Yeah, I'm not sure what the super is supposed to do on this one. It says on the screen, it treats super as a modifier that is often held down while pressing another key. If you click it once, it will turn yellow, indicating that the key is being held down. I'll look at it again. Yeah, super, and then my caps is on. Well, I turn it on my keyboard, but I don't think it matters. So I think I need to turn caps on there. Yeah, it didn't do anything. Yeah, that didn't do anything. I don't know what that's supposed to do. All right, workspaces are separate desktop screens that have different application windows and so forth. So there are two simple methods for switching workspaces. You can do Control Alt up arrow or Control Alt down arrow to switch between workspaces. And I think that's on this keyboard. Let me look and see if it'll give me a different see Control Alt F2. You see that? So this is what I was talking about, those alternate screens. So if I go Control Alt F6, it gives me that. But if I do Control Alt F1, I'm gonna go back to what I had before. These are those virtual terminals that I was talking about that you get, right? So I just leave it. Hit Control Alt F2. You can see that, and I'm put 2 here. Let me put 2 there. Let's go F3. Oh, hold on. Control Alt F3, right? And we'll put 3. 3. All right. So now if I go back, Control Alt F1, I had to hit it again. Control Alt F1. You can see I'm on 1. Control Alt F2. You can see I'm on 2. And then Control Alt F3. I don't want 3. Those are my virtual terminals, right? And then it says one method, perhaps the fastest, Control Alt up arrow to switch between workspaces. All right, so let's go check it out. Let's see if we can do it on here. What was it? Control Alt up arrow. All right, see, let's go here. Control Alt up arrow. It don't give me workspaces. I have to probably be in the GUI in order to get the different workspaces. I have to go with log in and bring up the GUI in order to get workspaces. And those workspaces are similar to that's not what I wanted to do. Go back. Those workspaces are similar to like this right here. So I can be in a different workspace or different desktop environment if I wanted to, right? That's what they're trying to highlight there. An advantage of the activities is overview is the windows can be clicked and dragged into the workspace. Remember I told you you could drop and drag. And then, you start the terminal up. If you're in the GUI, you can just click on it, or you can do Alt F2 if you wanted to. And then they were talking about logging out of the screen. You got the same menu buttons down at the left or at the top. I think it is at the top to log out. And then they got a shortcut if you want to log out. Remember, it's much easier as Windows L or Super L if you want to log out. Let's see if that works. What if I hit Super L? It'll log me out. No, I think that only works on the GUI. All right. And then here's a guided exercise. And this guided exercise is walking you through how to log into a Linux box. and they walk you through how to log in, go to GNOME, and they're doing this on the workstation. That's the key. So when you see that workstation right there, if you go back up here to your lab environment and you just open up workstation. So here's my workstation. I'm gonna hit enter. I know my password for student is student. Let me make sure I'm not in all caps here. So it's logging me in. It's gonna come up with the activities first. It's gonna be on at the top up here. We don't need to register the system. I would click on activities, and this is what you saw on the screen, where I have my info over here, the things I can drop and drag or whatnot. Other things over here, and I forget all the names. Activities, I forget message tray, and so forth, right? Message tray. I usually look at this like what user and what am I connected to in my volume. That's how I look at that. But if I click here, here's my terminal that gets opened. So now I have a working terminal. And what they're saying in the first exercise, which we're gonna go back to, table of contents, easier for me to get to. Guided exercise. They're like change the password. The current password is student, and change the password to 55 turn key the letter E being the number 3 and a K being capitalized, and then log out and then log back in, and then they want you to go through and shut it down. Determine how to shut down the user interface, like the graphical user interface, but cancel the operation without shutting the system down. From the system menu in the upper right hand corner, you can click restart or power or click the cancel button, and then you're going to reset the lab because you made some changes. And that's the guided exercise. That's the first part of chapter 2. And then we're going to start playing around with some more commands, which I started already playing around with commands for you, with the file command, the cat command, the date command. We'll go through those in depth. I started working with less. They're using head, W count. We'll do tab completion, right? User add. And the difference, remember, what's this first part right here? How should you read this? The actual command, the option, and then the argument. And then this slash right here, meaning that I have more information that I want to add to this. Like I'm not done with what I want to do. So it's saying go to the next line and complete what you wanted to do. And you see that twice here, right? History, we'll go through all of that. And then they show you how to jump around. But I think we did good for the first part, chapter 2. When we meet back up, this is why I like meeting on twice a week. When we meet back up, we need to make sure that we are finishing off chapter 2, and I'm probably gonna run through chapter 3. I'm probably gonna consolidate some of that stuff. I'm not gonna go through the guided exercises and stuff. I'm gonna leave that on you to ask your questions and to take time with it. But I want to make sure I go through things with you so you have that understanding. The goal would be to go through the rest of chapter 2, all of chapter 3, and then we'll probably try to do 2 chapters a week, 4 and 5, 6 and 7. So want to be able to knock those out. So study ahead of time so we can come together and ask questions. But also at the same time, if you don't, I'm going to go over the information, but I will be expecting you to at least have seen the material and not have, when we get on together at night, I mean on our Wednesdays and Thursdays, don't let that be the first time. At least read through it or listen to it. And then if you have questions or something like that, you like, I heard what he was saying here. I looked at it. It just didn't make sense. Can you explain this? And why do I even care to use this? Right. So that's where we want to be at. I'm gonna stop recording now.